Okay, so welcome to class for those of you who just got on in the video. This is mobile application programming for iOS, CS4530. We're going to just be doing an introduction today, but we're also going to be having a practical, using some tools to build an iOS application today. Many of you, I found before the course started, were thinking this was actually going to be an Android section. If you don't want to learn iOS development for one reason or another, that's fine. The course is about mobile application programming, however. This has the same number, whether it's focusing on iOS, which typically happens in the spring semester, or Android, which typically happens in the fall semester. You actually can't take both classes for credit. The reason why is there's a lot of overlap between the two. I talked quite a bit about Android in this class because it's the other very popular mobile application operating system. Occasionally I'll talk about Windows Phone, and the things that Microsoft is doing. But we try to get more of an overarching concept about how to do development for small devices that are in users' pockets, or slightly larger ones tending to be tablet applications. And what the principal differences are in developing for these devices versus desktop machines that are in front of you. If you just have an Android phone, you're toting a Windows laptop, you can still take the class just fine. You do have to have access to a Mac in order to do development for iOS devices, however. So you'll probably have to do your development here on campus, either using the machines in this lab or any of the other labs that use Macs. They're generally available 24/7. I've just found out that there is a set of machines that the library provides for remote access. So you can actually use an RDP client and access a Mac from home. I'm not sure if that experience is good or not. I just found out about it. So be aware of that. You should be able to do the entire course just being here on campus, but I know a lot of you want to do homework at home, such the word homework. I'm also thinking that that is a good thing for you to have, because the principal source of credit in this class is homework. In fact, we don't have any exams at all. So it's all about what can you do. Show me what you're doing. Because I think that's the best way to learn about iOS and mobile application development in general. Questions so far? Cool. Format makes sense. We're going to be doing some lectures, some practicals, and having video of that. Cool. The course website is something that I expect you to be going to often. I'll talk a little bit more about it further on here, though. Just to introduce myself, I got a bachelor's degree here at the University of Utah in computer engineering. Moved on to getting a master's degree in computing, and was working on a PhD in computing until I found that it was a little more profitable to own my own company, which I was doing concurrently with PhD. So I ended up doing that. So I am the Chief Technology Officer at Pixio Software. We are a company creating principally mobile software, almost exclusively mobile software, in downtown Salt Lake, in the City Creek block is where our office is. I got my emphasis in computer graphics when I was here at the University of Utah. Love talking about anything that's three-dimensionally rendered. Display systems are incredibly interesting and pretty much have everything to do with what people think software is what you see rather than what it does. So I think that's a great thing for people to be studying. At one point I taught the introduction to computer graphics here at the university as well. I've been working with iOS since iOS was iOS, pretty much. I wrote a program called Mobile Finder for iOS 1.4, which was a version before iOS version 2.0, which is when the original App Store came out in 2007. We were using a set of compiled headers that had been extracted from an in-memory representation of the operating system libraries. It's actually pretty Wild West and a lot of fun at the time. You've probably never heard of Mobile Finder, but it was on 1 in 6 iPhones in the world at one point. We had 2.3 million downloads. It was an open source project, so kind of fun. Been doing it for a while. I lived in Brazil for a little while. I speak Brazilian Portuguese. If you happen to as well, I love to talk to people in Portuguese. Learning Mandarin at the moment. I'm an engineer to the core. Love doing anything that has to do with solving problems or interesting technology. I love 3D fabrication, 3D printers, laser cutters, all that kind of stuff. I'm no mechanical engineer, but I tend to dabble with that kind of thing. I do a lot of electrical engineering type stuff. One of the one of the pastimes that we've had in at Pixio is just sending sounding balloons up into the air with sensor packages, cameras, and those kinds of things to take interesting pictures, use barometric altimeters. A balloon can go really far over a period of 6 hours. We've had to run into other states. Just that kind of stuff is a lot of fun. If you guys are engineers, you should be doing that kind of thing as part of your education. It's assumed that you're doing that kind of stuff. If you're not, why are you an engineer? You're doing cool stuff. So I am very much an engineer to the core and love to hear about the projects that you guys have. I read quite a bit, though I don't pass my eyes over text as much anymore. I tend to do Audible. But I like U.S. revolutionary biographies, fantasy and sci-fi books. Brandon Sanderson is one of my favorite authors. Love anything having to do with space. Anything that's over 100 kilometers above the surface of the planet is extremely interesting to me. All that kind of thing. I played a game called Warhammer 40K in the past. Hope there's at least a few people that know about the wonder that is Warhammer. And like I said, I love 3D fabrication. I think you should get to know your professors at the university. Please talk to me about stuff. I mean, I was not a student a long time ago. I know kind of some of the stuff that you guys are going through, how your classes can have this harmonic convergence of deadlines such that everything is due on the same day for some reason. Talk to me about things. Happy to work with you on those kinds of things. But for our class, in general, if you front load the homework assignments in my class, it tends not to clash with things in other classes, particularly with our final project. That's my intention, is to make it easier for you to be able to work on stuff in this class by making avoid the work that you have in other classes. It doesn't always work. Sometimes it does. Questions about me or any of my experience? Cool. I've been teaching this class for about 6 years now. So gone through quite a few students, quite a few classes, and we've improved the curriculum quite a bit along the way. As we go through the course, please give me feedback about the things that you're learning. If you're not learning things, I want to know that, because this is an elective course. You're here to learn about mobile application programming, not necessarily just to get your degree. So if I'm not giving you the information you want, I want to know. Cool. So the main entity that we're going to be using for organizing the class is a course website. It is found at eng.utah.edu/tilde and the class number, CS4530. Here you'll find a home section talking about me, my office hours, where I'll be, where the teaching assistant is also going to be. We're probably going to have 2 TAs. Right now we only have 1 slotted. His name is Sam Trout. And other information about the course. We also have a section for schedule and a section for programming. Schedule is where I'm going to be posting videos of the class, the slides that are associated with each lecture, as well as readings about the topics that we discuss. And the expectation is that you at least skim the readings before coming to the course. So I'll have that stuff posted for you. The section for programming is where you will find your homework assignments. So there are several projects you're going to be working on in the class. Likely there will be 5 programming assignments plus a final project and 1 written assignment. So no exams in this course. So it's all project-based. I don't necessarily email out to the class the fact that there are programming assignments. I expect you to just be checking this website often, coming to class, watching videos to know about when there are things due. So this is the de facto place where you will find all of the needed information for the course. I've had a few requests for moving to Canvas for some of these components. I need to make sure that Canvas actually does the things that I want. I post 50 to 60 gigabytes of video every single semester, so I need to make sure they have the capability of that before I jump to a tool like Canvas. But if that does happen, I'll let you guys know. As far as you're concerned, this is what we're going to be doing for the whole semester, unless otherwise announced. Okay. Part of that website, on the home portion of the website, talking about Center for Disabilities, the breakdown for grading and such is all there. But I wanted to have you guys pay attention particularly to the cheating policy for this course. It's pretty black and white. Essentially, you will be turning in a zip file full of code to me. If the stuff that is in that zip file was not all written by you, you're probably cheating. And that includes copying and pasting code from the internet, getting information from your fellow students, and even the use of libraries and template code. There's a specific set of code that I allow you to use that is auto-generated by the Xcode development environment. Other than that, anything you turn in should be written by you, period. Even the use of libraries. I want you to talk to me about the use of libraries. So it's very black and white. This is an elective course. I hope that you're all here to be learning about mobile application programming. It's not part of the usual fare. I expect incidences of cheating to be very, very low. That being said, I have found people cheating in my course before. I have failed people for cheating in my course before, and I've prevented people from graduating because they cheated in my course. Do not do it. Are we clear? Good. Let's move on. Because I would like to play a game with you guys. I like this game. I do it pretty much every semester because I think it's a lot of fun. We're learning about mobile application development. That means that we're really concerned with the thing that people are very interested in these days. Phones. Phones. People talk about their phones and their mobile devices and the apps that they use and all that kind of stuff all the time. It's an amazing change in society in the last 10 years. So let's learn about these things. Let's talk about their history, and let's talk about where they are in actuality. I have 6 phones pictured here. I would like to know what they are, who makes them, and what's their model. What is their marketing mantra? What are they actually called? Can you tell by look? Everybody's got to recognize at least one of these.
Yeah.
Come on, by raise of hands. What do you see? Yeah.
The top right is an iPhone.
The top right is absolutely an iPhone. Do you know which one?
Tell you what version.
Couldn't tell me which version. Can you tell me what version it's not?
7. It's not the 4. It's gotta be 5 or 5.
5 or 5S, 7. What do you think? It's newish, I'll tell you that. It's not an iPhone like an iPhone original or an iPhone 3GS or something like that.
5. 6.
It's not a 5, it's not a 5S.
6.
This is a 6. So how do you know it's not a 7? You kind of don't, unless you throw it in the sink and see whether or not you can pour water in it and have it fritz out or something. There's a tiny little bit of change of pixels down here for some reason. Because at this point they didn't have courage. Now they do have courage. Apparently. I don't know how I feel about that. I have a 6 in my pocket, so. Other phones. What else do we have here? Apple does not own the world, despite what they think. Yeah.
BlackBerry Z10.
That is a BlackBerry. It is in the Z series. It's not a Z10, but wow, that was pretty good. It is actually a Z30, I believe. Any others?
Yeah. Middle bottom, is that a Galaxy X6?
The middle bottom,
Nexus.
that is a Nexus, yes. Do you know which Nexus?
5?
Not a 5. Though the Nexus 5 is an excellent device. I've walked around with that one for a good long time. It is the 6P. Yep. Any of the others? Yes.
Top middle is like a Palm Pre.
Palm Pre, nice. Not many people get it, actually. I was very surprised this semester. Someone in the last section got it as well. It was a Palm Pre. That is actually not the Palm Pre. It's a little later. It's the Palm Pre 2. Any others? Yes.
Lumia 520, one right.
It is a Lumia. It is not a 520, but they do look fairly similar in their casing. One of the ways that you can tell is they were all excited about the fact that they have 5 columns for their gridded structure. It was one of their pieces of marketing. Now with 5 columns, it's like, really? Okay, why not? I believe that one's a 920. So fairly new. It's about a year and a half, 2 years old. What about top left? Anybody? This one is the oldest phone pictured. But surprisingly, there's a huge market share for these.
Looks like a Sidekick with the screen hookup almost.
Interesting. No, it's not the Sidekick. It is Nokia. This one actually, at this point, is probably 4 or 5 years old. But think of something that's 4 or 5 years old. It's not that old. Somehow it is old in phones, but if you think of like, oh yeah, I've had a T-shirt for 5 years, like it's still a good T-shirt.
Is that the N8?
It is the Nokia N8. But I think you're cheating. The Nokia N8 is a device from a very long time ago, but not that long for most people. So that's what we have here. Good job, guys. Actually, I haven't had people get the BlackBerry Z series in quite some time. So if I were to write software for these, what development language would I be writing that software in? What's kind of my day-to-day like? What am I writing? C, C++, Java, C#, Scala, Haskell? What am I writing software in? I can introduce myself as a mobile developer or an iOS developer, but probably you're also going to develop yourself as a Java developer or a C++ developer or a C developer. Implementation languages are a big deal. So what do I write software for these in? Individually.
Is it C# for the game?
Yep, in general, for the Windows platform, you're going to be using C#. Though it's more than just C#. You can use the .NET framework. At one time, at least, you were able to write Visual Basic and a variety of other languages. Cool. What are the languages?
Java for the Nexus.
Java for the Nexus. Yep. Android is almost exclusively Java development. Is it the only development language for Android? No, actually it's not. It's just the main one. You can use C and C++ using the native development kit that Android provides.
Scala too, right?
And Scala too, and Rust and whatever else you want to have compile there and actually work with the JNI. What else? And what is the development environment for these others? Or sorry, not the development environment, the implementation language. Yeah.
Objective-C and Swift for the iPhone.
Objective-C and Swift for the iPhone. Yep, and Objective-C is absolutely still current technology, even though Swift is being pushed rather hard. What else? For the BlackBerry, if I was going to write new stuff for the BlackBerry, because I have this great business idea of working with this boneyard of a company, what would I write it in? Actually, you'd write it in much the same way as you'd write stuff for Android, though you'd definitely use a different set of libraries. You'd probably write it in Java. What about the Palm Pre? C++?
Is it WebOS?
Yeah. It is WebOS.
So like HTML.
It would use HTML, CSS, and JavaScript. That's correct, with a bunch of extensions. And the Nokia N8. What do I write software for the Nokia N8? In fact, maybe this is a better question. In fact, I kind of jumped the gun. What operating system does the Nokia N8 run? Symbian. What's Symbian? Actually, I'm quite surprised there are several of you that know what Symbian is. It's, or at least up until 2 or 3 years ago, was the world's most popular phone operating system. Pretty cool, actually. But you didn't know because it was all running on feature phones. Palm Pre, we said, was WebOS. What is the operating system on iPhone? iOS. Nice. The other ones? BlackBerry? What does it run? It was BlackBerry OS. Yep. Nexus runs on Android, of course. And what is the name of the operating system that the Lumia 950 runs? Windows 10. Note that is not Windows Phone 10 or some phone-specific thing. It is supposedly the same operating system running on your desktop machine, which is an interesting play for Microsoft. Cool. So those are the OSs. So what about, and the development environments, or sorry, the development languages as well. Swift, Java, Java.NET, C# generally, those kinds of things. So more about my day-to-day. If I were doing development for Android, what is the set of tools that I would be using? Generally, people use an integrated development environment in addition to other tools when they do development. What is the name of the IDE that is generally associated with the development of each one of these? If I'm writing software for the iPhone, what is the name of my IDE? Xcode. Yep.
I was going to say Xcode.
Yeah. What about for Android? Android Studio. There are a few other options, but in general, you're going to be using Android Studio. Windows Phone? Visual Studio. Yep. What about any of the others? In general, they just didn't quite get their own development environment associated with them, so you'll tend to use some of the other development environments in order to do it. But they'll have a set of libraries, extensions, and possibly third-party compilers associated with them. So we have the Symbian SDK, the Mojo SDK for these guys, iOS, .NET, Android, and the BlackBerry JDE. And I thought I had one more slide. Sorry, I'm kind of out of order for our game. I think it's important to learn about the history of these devices because it very much affects the day-to-day that you are going to have writing software for mobile devices. I mean, you think about BlackBerry being dead and the Palm Pre being completely dead. That belongs to HP at this point. But like 5 years ago, they were current technology. That is not that long ago. Like people say that computer science and programming and all that kind of stuff moves fast. Like this is lightning speed fast. It is the fastest part of computer science. So you really need to stay on top of these technologies. It's so fast to get outdated in these kinds of things. And I try my best to stay on top of iOS and Android and the Windows technologies in addition to the other stuff that I find myself doing. I've been doing a lot of development in Linux at the moment, and so I'm not as sharp as I would like to be on everything. So when I fumble, please cut me some slack. I can't write iOS code all day, every day. So we're going to be learning more about iOS and the Apple products. But you need to make sure you're also talking about Android. This is a mobile application development course. Why is it, other than the fact that it fit in with your schedule, that you're taking the iOS course rather than the Android course? There are a couple of reasons here. Number one thing that I get from a business perspective is a very small percentage of iOS device owners actually purchase software. This is backed up by a lot of data. There are way more Android device users out there than there are iOS device users. However, depending on the metric that you use, the amount of money spent on software is fairly comparable. And in fact, iOS probably makes more on direct software sales. Why is that? Now, that's more of a marketing question, but it affects us. Why do you think? Yeah?
You pay more money for a phone, so they're more likely to pay like software.
So they self-select. There's some component of self-selection. People are willing to pay more for an Apple device. There is no like bargain bin $50 phone that they offer usually. And so they're going to be more willing to spend money because they probably are in a different economic bracket. Yeah?
You know, on Android, you find a lot of like open source apps and just download like APKs instead of having to go through like, you know, the iTunes store or the App Store like on Apple. So you're not really forced to pay for a lot of the open source stuff.
So the nature of the software distribution system actually has an effect on this. Android is more open, whereas Apple is more closed and has a curated experience. Absolutely. Yeah?
I think similar to that, as I'm for now, gift cards saved up from back when iTunes used to actually, like, you actually had to pay for your money, or pay for your music instead of streaming it.
Interesting. So just a huge lump of existing gift cards that people are still burning through. I hadn't heard that one before. Cool. Where can I get access to this lump? In a legal fashion is what I'm asking. So that's one driving force. You could completely disagree with me on this point, but the numbers tend to back it up. Another reason, fragmentation. What's fragmentation? People throw this around a lot about Android. They say it's fragmented. What do they mean? Yeah?
Like when Apple makes an iPhone, like there's a very set type of hardware, like the processor and all the pieces are known. Whereas in Android, like the price range and the models vary drastically. So a developer doesn't know what their target platform is always going to be.
It's principally a change in the way that the technology is being disseminated. Google built an operating system, not a set of hardware. They are now. But Android is an operating system that phone users or phone manufacturers can deploy, whereas iOS can only be deployed to Apple devices on hardware that Apple also creates. So Apple is vertically integrated, whereas the Android system is not. And so we get fragmentation because of that. There are a bunch of different companies that make Android phones. There's only one company that makes Apple phones. And so how does this affect you? Why does this matter? Isn't it just a business thing? You know, just because Apple's a jerk and they want to have it all, right? Well, it affects you a lot as a developer because you have to pay attention to your users. Your users are going to want to use your software on whatever device they happen to own. We've encountered that just with the course here. People are concerned about, oh, I don't have an iPhone, so I don't know if I want to do development for iPhone or whatever. You know, what devices are out there, what devices are available, and what devices your potential users are using are very important questions. So particularly with fragmentation, it affects your ability to do debugging. If you've got a set of 5 or 6 different devices that you want to work with for iOS, you can have every one of those devices on your table and do testing with the actual device. With Android, there are literally tens of thousands of devices at this point, order magnitude 5, that run Android. You cannot own each one of those. It is impossible. So you can't actually test on all of these. So you have to do some kind of class testing to try to catch most of the users that are going to be working with your software to actually test their experience. The instances of incompatibilities, crashes, and other things like that, you have to pay a lot more attention to on Android. It costs more because of that development experience, the testing experience. So in some ways, development is more expensive on Android. In some ways, it's not. But it affects your day-to-day, absolutely. Startup companies tend to prefer targeting iOS platforms before they target Android. Again, I'm just saying this as an assertion from what I've seen personally. It's very, very, very hard to get a metric on that. But I do think this is probably true. If this is true, why would you think that would be?
For the same reason fragmentation makes it difficult to program for Android. It's easy to program for iOS. If you do software on one that works really well, you can potentially port it over to Android later.
So more targeted experience. Another reason I hear people talk about is early adopters. You know, you'd think, well, wait, early adopters buy Apple devices? Sometimes. But I would think there actually is a larger percentage among early adopters that own iOS devices compared with the rest of the population. So that's another reason. Also, startup companies are usually creating new products. New products usually cost money, and if it's not something that people actually have already, you're creating something brand new, you're asking them to add to their set of owned things. They're probably affluent people as well. So that tends to go towards the iOS market. These are important questions. Even though they are economic and potentially putting people into economic classes and things like that, it's important. It affects you. You need to know about the market that you're creating your software for. Because just like an author doesn't write a book for no one to read, a software developer doesn't write software for no one to use. You need to know who you are writing your software for. Otherwise, why are you doing it? Other than just, for me, I'm your #1 target market at the moment, I would think, so you can get through the course. But that's not what I'm teaching you guys to actually be doing this for. And I hope that you've got a larger concept than that, than just getting through the CS 4530 course. This one is becoming less true and also becoming more true at the same time. Hardware running Android is arguably inferior to that of other companies, particularly due to the price of units. So, have you ever walked into Walmart, walked down the tablet aisle, what do you find? Right at the end of the aisle. Some kind of budget Acer or RCA tablet, and what does it cost you? Less, man, $59.99. You can get an Android tablet for like the price that you would get it like as you're walking up to buy your gum. They are so cheap and so crappy, and you still have to deal with it. Because they're brand new devices. These are current devices. This is not targeting something that somebody had in their closet or they haven't upgraded in the last 2 years or whatever. They can walk into Walmart right now, buy a new tablet, and they want to run your software. Right? So you both have to support the guy that's paying $600 for his brand new Nexus 6P or whatever, and you have to support the guy that's paying $60 for his crappy tablet that contains hardware from 5 years ago. And on top of that, they're probably not all even running the newest version of the OS, even the guy who paid $600. You know, nobody's running Nougat. Like, I'm writing software against Lollipop, and even then I feel kind of progressive, you know? It's just the way it is. These things all affect you. And as mobile developers, you should know about these constraints. If you say, hey, I write apps, people are going to assume that you know something about the Android environment and everything that goes on there. They want to know about what Microsoft is doing. Why are they doing it? What are the pros and cons about this? How does this affect the set of technologies that are available to you and the set of libraries that are available to you? How does it affect your cost of development? How does it affect your consumer? What options do they have? Think about all of these things. These things are important. Anyway, don't want to belabor the point too much because we also want to write software today. Questions on this so far? Any other thoughts? Cool. Please look around. Pay attention to what phones people have and why they have them. So what are we actually going to be doing in this course? We need to focus. We have a lot to do in this course. This course is supposed to be quite difficult and have a lot of work in it. I hope that you've talked to other students and that you've heard that before you even started taking the course. I tried to send out an individualized email to every one of you letting you know this is a difficult course that has a lot of homework. That's our goal. Our goal is to take developers who have had object-oriented programming experience all the way up through being able to create applications that are worthy of being potentially sold to someone on a store. That's what we want to do in this course. One of the things that I hope to be able to have you guys do in this course also is a final project of your own design. So kind of proud of doing this in our course. 35% of your grade is a final project. I will be providing a final project document for a kind of canned final project you can do just like any one of the other homeworks in this course. But if you would like to, you can pitch me on a product that you would like to create of your own. You'll provide a specification document for that product, and if it fits as a final project for this course, I can have you do that project as your final project for the course. Last semester, about 1/3 of the students did that successfully. And the reason why I do that is because I want you guys to be learning what you want to learn, to show what you want to show. In particular, you will be able to get employment, or if you have more of an entrepreneurial slant, you'll be able to get clients based on the portfolio of software that you've written. So your software should be very nice looking, look really, really good, and be impressive. Because that's what you're getting out of this course, in addition to what you learn. The final project, you're going to be able to point at and say, I made that. You can go download it, and I wrote it all. And they can have questions for you about it. You can show what your chops are. That's what I'm after. That's what I want you guys to get out of this course, is that value, more than just the 3 credit hours. So how we're going to do that is using iOS development, writing iOS apps, and Xcode. Xcode is an integrated development environment that contains a bunch of additional components. The main thing you're going to be working with is its editor. In Xcode, they have an editor that has some advanced features. They're continuously compiling the code that you're writing to be able to give you feedback on syntax errors. So evaluating your code from a syntactic point of view. And it also gives you suggestions as to why something is syntactically wrong and what it thinks you meant. So this is becoming the norm. This has not always been true. But Xcode does support that. It was popularized by Microsoft with the term IntelliSense. And so a lot of people still refer to it as that. It's continuous compilation of the code, gives you the feedback. I don't know what Apple actually calls it, come to think of it. And for Swift, it sometimes is kind of garbage. For Objective-C, it's great. Unfortunately, Swift is still kind of a new technology. Other thing, Xcode will be very confusing, and working with this technology is extremely hard for you if you don't know about one simple trick. One simple trick is hold down the Option key on your keyboard and click on any identifier in a source code file, it will give you documentation about it. It will either open the local documentation if you have the documentation installed in your machine, or it will open a web page and give you documentation about that. So it's kind of JavaDoc style, but it doesn't get in your face about it. It's kind of like JavaDoc does in a lot of other IDEs. So option click on things if you want to know what they are. It has a debugger or compiler based on LLVM. They used to use GCC and GDB, and you still actually can use GCC as the compiler with Xcode. But LLVM is the compiler that they're supporting most now, and the associated tools around that. So you can do development for iOS devices using some other development environment like AppCode, or if you're a Linux guy and you just really want to use Emacs, you can do it. You can set up a set of command line scripts to be able to do building with Xcode. You use the command line components for Xcode, and you can do that. But more than likely, you're going to want to use Xcode as an IDE. It also has a profiler that allows you to see memory usage and CPU usage, even breaking down into what parts of your program are you consuming the most CPU time, as well as a tool called Interface Builder. Interface Builder is a graphical tool that allows you to compose user interfaces made up of buttons and images and switches and all that kind of stuff with standard controls. Our course is a bit different from tutorials and other things on the internet that you'll find, even possibly from courses at other universities, in that for the first half to 2/3 of the course, we don't use Interface Builder at all. I want you guys to get used to using the code, writing code in order to create the experiences for the user. Interface Builder is a great tool, but in many ways it creates this feeling of magic. There's some stuff that it does. And if you go and look for how to do something online, you just get a bunch of people saying, oh yeah, in Interface Builder you click this and do that, and it doesn't really come up with a solution to your problems. So from the get-go, I want you guys in the code, writing the code. So we're going to do it all 100% from code from the beginning. And we'll make it difficult if you're trying to look for solutions to problems online, because it's more common to find some solutions in some areas based on Interface Builder than it will using code. But I found over and over and over again, this is a good way to teach this course. And I think it gives you guys a much deeper and broader understanding, which is the difference between just kind of taking a tutorial online versus a university education. So that's what we're after. Questions on this? Cool. We will have our practical today, and we'll actually see Xcode, use Xcode. Talk more about it. Last thing, last slide, I promise. This is what a project looks like with the open up in Xcode. Once you create one and give it a name, here I just called this one test. On the left-hand side, you have the set of files that are associated with the project. The project file itself is represented by a blue icon at the top and contains information about all the settings inside the IDE, as well as what files are linked. It's not done on a directory structure. It's based on files that are referenced by the project file, though generally all of the files that are in a directory are also referenced by the project file. But the files can be anywhere on your system. They're just being referenced by the project, so be aware of that. You'll have a set of code files there, generally ending in .swift. If you find anything that ends in .h or .m, that's probably written in Objective-C. There's files called storyboard files. Those we won't be using for the first bit of the course. Those are the Interface Builder files. A set of graphic assets. It looks like a folder because it kind of is. It contains images that you can include in your program, as well as files that end in .plist. A plist stands for property list, and its most comparable technology is JSON. It contains a graph of objects referenced either by an array or a dictionary, which is a key value store, and primitives, strings, integers, booleans, and so on. So property lists can contain any kind of object graph, but this property list contains information about the application itself. Property lists are actually a really great way of storing information for your application if you're just using Apple platforms. Property lists are also available for use in pretty much every other development environment as well, because they're one-to-one convertible nearly with JSON. and they are in XML format. So it's a cool file format.Plists are all over the place on Mac platforms. In the middle, we have our code editor. That code editor, you can actually create a split, and it can have 2 editors at once using these buttons up at the top right. So you have single editor, companion editor, and source code management. So you can compare it to previous versions, is how that little toggle works. These toggles here allow you to have these work as drawers. You can push the left-hand side away, you can push the right-hand side away, and you can bring the bottom drawer up. The bottom drawer contains your debug console and watch list for variables when you're doing debugging. The right-hand side may be somewhat different than an IDE that you've used before. This contains the inspector. Inspector is a common concept with a lot of Mac applications. It gives you more information about the thing that you're currently looking at. So if you're in, say, QuickTime and you're looking at a video, you can open the inspector and find out more about the video, its length, what its format is, the bit rate, all that kind of stuff. It's kind of additional details. Normally you right-click on things to get more information in other IDEs, whereas the inspector shows it all. So as you select the different elements on the left-hand side, the inspector will change. The reason why I mention it is the inspector contains a lot of options that you can only access from the inspector. You don't get it from any other menu. So be aware that if you close that menu, there might be some things you can't get at. In general, Xcode looks a lot like other IDEs. This did not used to be true. It was a very, very different kind of experience. But as of Xcode 5, it should feel familiar. If you've used Visual Studio or Android Studio, IntelliJ, any of those, you'll feel pretty much at home with everything except for maybe the code. Who here has actually written some Swift code before? A few of you. Who here has actually done mobile development before? Probably the same people, but I'm not making the assumption that any of you have done any mobile development before, but that can help. By raise of hand, who has used a non-scripting language to create a program that has a user interface, something that I can click on with a mouse? By raise of hand. Very, very high, please. This is an important question for me. Who has only done console applications and has never done any other kind of development? Nobody. Should be one or the other. Those should have been mutually exclusive. So I'm going to basically assume that you guys have used something that is of that type before. In general, what technologies did you use in order to create user interfaces? Qt? Anything else? Swift and Objective-C, okay. JavaScript, okay. That's arguably a scripting language, but yeah.
Visual Studio.
Visual Studio and C#?
Yeah.
.NET Framework stuff, okay.
Java Swing.
Java Swing, great. Not AWT? Why not? Anything else? Cool. That pretty much covers the gamut of what a lot of people have had experience with. Not a lot of people have done Qt. That's cool that you've done that before, though it's very popular on Linux. So a lot of these concepts are shared, which is why I ask. UIs tend to be event-based programs that have to do with some kind of an outer loop that the operating system runs for you. So I want to explain it in that context. Okay, every lecture I'm going to have this. I think it's very important, even though it kind of seems like a waste of time. It's a break. I want to have at least a 4 to 5 minute break between the lecture component and the practical component. Study after study has shown that people's minds really only work for about 45 minutes, and my instruction will be more effective if we have a break in the middle. So stand up, get a drink, whatever it is that you'd like. I'm going to put on a piece of music. When the music is over, the break's over.
I'm just wishing to participate.
Oh, you're okay.
Because I did.
If you want to participate, that's fine.
Absolutely.
Yeah. In general, when I'm trying to pull answers out of students, just keep quiet.
Yeah, I did.
But if you're
I think I did. I waited. I looked at some honors and nobody has smartphone. That looks like it.
feel free to ask questions.
Cool.
I do want to try to get participation.
Yeah, I'll do my best.
Thank you. Just a quick question. Is the other section of this class that's right before this, is that also iOS? Okay, because I'm just looking at the time. If there's still spots on it, I should probably just ask it. I was just thinking David in earlier.
All right. So let's go ahead and start a practical portion. I try to go at a speed where everybody can go along with me and actually program along with me, though sometimes I speed up and I apologize when I do. Kind of have to make a good balance between going too slow and going too fast, and it's never right for everybody. So I apologize if it's too slow, and I apologize if it's too fast. So you can open Xcode on any one of the Macs that are in front of you. You can log in with your UID and password. If you have a Mac of your own, feel free to use it. You'll be given this welcome screen when you get into Xcode. Has recent projects on the right, and these two buttons allow you to create projects. This one allows you to check out an existing project from a source code management repository, generally Git, though it also supports Subversion. There are two kinds of projects that you can create with Xcode. One is called an Xcode project, and the other one is called a playground. Playground is a set of technology that Apple has come out with to try to encourage people to accept the Swift programming language and this programming paradigm that they're working with. Continuously evaluates a Swift program as you write it and produces the results. Kind of a cool little technology they've got. We're not going to be doing anything with them in our course, so don't create playgrounds as we're working with our projects. But if you want to work with it just to play with Swift, it's a wonderful way to get to know the language. So we'll be creating new Xcode projects this way. You can also do that by saying File, New Project. And you'll be presented with a template chooser. So each one of these icons represent a template that has a set of predefined files that are filled in with dialog boxes that are going to come up next. So this is the template code that you guys are allowed to turn in with the course. That being said, I want you to look through all of the files in the project and understand what those files are. I want you to have a mastery of particularly the package of code that you're going to be providing to me. So if you're linking in any other libraries other than the ones that are provided directly by Apple, talk to me about it. And in general, if you keep that, you're going to be in a good place with our cheating policy. So we'll work with a single view application template today. Yours will probably look a little bit different. The version of Xcode that's installed on these machines is targeting iOS 9.3, which is fine. The difference between iOS 9 and iOS 10 for us are not a problem. So the single view application is the template we'll start with. If you click next, it will ask you some questions. Again, this might look slightly different, but should be fairly similar. Product name, just call this Light. You can call it whatever you want. That's what I'm going to call mine. The team is a set of certificates and provisioning profiles that you need in order to deploy to an actual Apple device. They do code signing even during development. So if you're just going to be developing using the simulator, which is all we require for the course, you don't need to select a team. Organization name, just put in your name is fine. Organization identifier should be a reverse URL. The reason for that is that the bundle identifier comes from the organization identifier, and the bundle identifier is a unique identifier that says this is my application when you give it to Apple to put on the store. The bundle identifier doesn't change once you've actually given it to Apple. So typically it's that reverse URL. So I tend to use edu.utah.cs4530 for our class. But do what you choose. Language, we're going to be working with Swift. Objective-C is definitely still current technology, but most applications do tend to be created in Swift, new applications, and Apple encourages that. That being said, there are reasons to create new applications using Objective-C. Devices, this tells you whether you're building for all iOS devices or you're specifically targeting iPhone or iPad. It affects the way that the project is created. And unless you are creating something you absolutely don't want to be on tablets, try Universal. It means that you have to support a few different screen sizes, which is a good thing because even iPhone has a bunch of different screen sizes anyway. So you can't get away with just assuming one screen size. Uncheck all of these boxes. Core data is a technology we'll talk about a little bit later in the course. Unit tests and UI tests are great, but they do complicate the project, and we don't really need them for our course anyway. So just uncheck those to make your project file simpler. Choose a location. It will create a Git repository for you if you want it to. I encourage that when you're doing development in my course, so that if you get used to using a source code management system that's a lot more like actual professional development, it also allows you to try some things in your source code, and if they don't work, you can go back to a previous version very easily. Source code and development are just hand in hand nowadays. You have to know how to use source code management. Git, Subversion, whatever it is. Choose one, but move with it. Choose Git. It's the best. I'm going to create it on the desktop. So now we've got our project here. On the left-hand side, we've got all the files associated with the project, the ones that are linked in. We have the editor in the middle. Notice that because I have the project file selected, it is not a code editor. It's actually editing the project file. On the right-hand side, I have this inspector. It tells me more about this file and what else I can find out about it. If you select one of the source code files, changes the area here, also changes the area here. If you right-click on any file on the left-hand side, you can say Show in Finder. This will actually show you what file is being represented by that. So on my desktop, I have a folder called Light, and I have an Xcode project file and a folder containing these source code files. So these are the Swift files that are linked here. The info plist that's linked, that is the manifest for this application. This is the set of assets associated with my application. It will get filled in principally with images that you want to represent in your app. And this has to do with localization, translating your application into other languages. So we're mostly going to be working with these. When you turn in homework to me, I'm expecting you to zip this stuff in a zip file and send it to me. If you want to zip the outer folder, that's also probably fine. But don't just zip the source files or something like that. I need the whole project. In here, we have this listing. The storyboard files have to do with Interface Builder. If you click on here, it gives you a what you see is what you get type interface, a WYSIWYG interface, where you can drag and drop buttons and things like that. But I want you guys to be doing this in code. So we're actually just going to remove these storyboard files. You can right-click here and say delete, or you can press the delete button while it is selected. Notice that it's asking, do you want to delete the file, or do you want to delete the reference to the file, or actually delete the file? We want to delete both the file and the reference, so you can say move to trash. Do the same here. So we're almost done with a template that doesn't use Interface Builder. The last thing that we need to do is the manifest references those files. For some reason, they didn't elect to have the manifest be modified when those files are deleted. So you have to click on info.plist, and there are several elements in here. The first is your native development language. I'm going to be speaking English in this class, though my company wouldn't exist if it weren't for localizing into other languages, so please pay attention to non-English speakers. Executable file name, the actual bundle identifier, those are created for you based on the selections that you made in the template and other elements. But the launch screen interface builder file and the main interface builder file were referenced here. So we want to get rid of them by clicking the minus button. So at this point, this is a project that doesn't use Interface Builder. In the past, I've distributed a template to you guys to do this for you, but I just found it was more trouble than it was worth. Just use this template and remove Interface Builder files and remove them from the plist. So there we go. Let's actually start writing some code. Make this thing compile. appdelegate.swift, sorry, single click, not double click, will contain the equivalent of the main method that you'd find in other development environments. The closest thing that we're going to find to a main method in iOS is this function declaration inside an application class that is an application delegate. We'll talk about all these terms. I'm just going to cover a few bits as we go today. I'm going to talk about the Swift language in particular in the next lecture. Let's see how far we can get just doing one piece at a time. This is a function declaration in Swift. You know because it starts with the func keyword. The name of this function is application did finish launching with options. So that's the actual name of the function. In Swift, the parameters to a function are found interspersed with the name of the function. So it's supposed to read somewhat like a sentence. So application, this application, did finish launching with options, these options. So kind of odd if you've only ever worked with C-like languages before, but there are a collection of languages that work this way, Objective-C being the main one. So this is pretty normal for Apple fare. I know this is going to be really weird for some of you people. You're going to be like, ugh, gross. But I guarantee it, the longer you work with it, the more you'll like it. It's really, really nice not to just have like this blank parameter list with thing, comma, thing, comma, thing, comma, thing, comma, thing, comma, thing at the end. It makes your code much more expressive. I much, much, much prefer it to C-like comma-separated parameter lists. So try it out. You kind of have to because it's Swift. So there's your function declaration. This application object is being passed in. The application parameter's name is application. Its type is UI application. You know because it's application : UI application. Notice that this goes from line 17 to line 18 with a blank. That's because it's automatically word wrapping for me. The launch options are an array of type enumeration whose name is UI application launch options key. And it has this little question mark that we'll talk more about. This function's return type is a bool. So the return type for the function goes on the right-hand side after this arrow. If there is no return type, there is no arrow, and it's just assumed to be void. So this function is an example of one that doesn't return a value. So because this one returns a bool, we return true at the bottom of the function. So kind of go with me today. This is going to be a bit of a baptism by fire with Swift, and we'll talk more about these elements as we go. So let's get this thing actually showing a user interface. Because we're not using Interface Builder, we need to create, at a minimum, a few user interface elements to represent our application. Otherwise, it's nothing. So we have a declaration here already at the class level for an object that is a window. A window is used to show anything that the user can see in the application, and it's a hierarchy of view objects. A window is a view object, and it can contain other view objects. So we need to assign to this existing variable. So we can say window, win, equals a new window. And you don't actually use the new keyword. You just say UI window, which is its type, followed by empty params. That constructs a window and assigns it to the window variable. In Swift, this declaration is more than just a variable. It's actually a property. So it has a getter and setter associated with it. So this is an active assignment. It's not just assigning to like a pointer in memory. It has additional code associated with it. So anything that is using the app delegate can notice that the window has changed. In addition to creating a new window, we want to display that window. By default, windows are invisible. And also there's the concept on iOS and Mac OS X actually, of a key window. So you have the key window, which is the current window that the user is interacting with, and whether or not it is visible. And we can set both of those properties at the same time by calling window.makeKeyAndVisible. So it pops up this set of method calls that are available on the window object. If you hit enter, it will actually insert this little question mark. You've probably seen a few of them already. This question mark has to do with a language feature in Swift called optionals. In Java, any class type object can be null. You have the ability to have the non-object, the thing that is not. But if you have like a float or an int, the lowercase versions, you can't assign it to the null int. There's no way to do that. Primitives have to have a value. So in Swift, this is actually added to the level of all objects. All objects, primitive or otherwise, can be optional or not. So you can have an optional int, an optional float, an optional UI window. You do that by adding the little question mark to the type when you declare the variable. So if it's non-optional, you are required to provide a value when you create it. And that has to do with the larger design goal of Swift of being a safe language to program in. The design goal for Swift is to be a language that is easier to write programs that are free of errors rather than easier to write programs. So you'll find there are several annoying things with Swift, but they're imposing you heavy-handedly, just like Apple does most of what it does. That being said, Swift is a wonderfully good language. Sometimes the tools are not great, and I have a lot to complain about that, but the language itself is pretty great. It really, really is well thought out. So that creates our window, makes that window key invisible. However, there is one more thing we need to add to this. Because this is a window object, it's expected that the window has some subviews in it. This is a view hierarchy. We'll talk about the view hierarchy quite a bit. And it's rooted at the window. So if you run the program on iOS 9.3, it will actually run and show you a black screen. If we run it on iOS 10, which is what I'm set up for, it will actually crash and say, hey, you don't have any views in your window. It's expected that there's going to be some views. So I run this, opens up the simulator, and says SIGABORT. If we scroll up in our listing here, it says terminating app due to uncaught exception, internal inconsistency exception. The reason is that the window is supposed to have a view in it. Specifically, the way that the window wants to receive its view is via an object called a view controller. We'll talk more about view controllers later on in the course. I want to focus on the user interface elements first for simplicity. But Apple very heavily uses the concept of model view controller. So the window needs to have a view controller. We happen to already have one of these. That's the other file that's being specified here, viewcontroller.swift. This is a small object that is subclassing the object UI view controller. It's actually called view controller, but you can call it what you want. You can call this the light controller. You don't have to change the name of the file, though typically you do when you do something like that. And rename. You can use refactoring as well. I've gotten out of the habit of using refactoring because they were so horrible in the first versions of Xcode with Swift. So this view controller we'll talk more about, but it has one property that's very important. A view controller controls a view. So it has a property called view that is the view that it is controlling. So we can add to our window another property assigning to its root view controller. So its root view controller, we want to make one of these, a light controller. Notice also the language doesn't have semicolons. You can add them, but they're completely redundant. You only need them if you want to have multiple statements per line. So this creates a view controller called light controller, assigns it to the window. And part of the construction of a view controller is constructing a view. So at this point, we can actually run this and it'll work. And it gives us a window. However, that window is black. And the view that it contains is also black. So just to make sure this is working, let's make it be not black. We can ask the window for its root view controller, and then access the view property of that view controller. And we can access the background color of that view. Colors in iOS are somewhat similar to other platforms you may have encountered. Typically, you think of a color as an integer usually. 8 channels red, 8 channels green, 8 channels blue, 8 channels alpha. That's how the internal storage works for most colors on iOS, but it's represented by an object called a UI color. So the UI color class has a few colors that are predefined for you, so we can access one of its static members, such as black, brown, cyan, dark gray, so on. Or you can instantiate your own color. So let's say brown. Run this. We should get a brown window. So we have a window, and inside of that window, filling up the full size of the window, I know there's some black bars here, I'll cover that later. If you're running on an iOS 5 device, it would actually fill the, an iPhone 5, it would fill the entire space. No, iPhone 4, it would fill the entire space. The window contains a brown view that comes from our root view controller. So if you're not getting brown, something's wrong. Or red, or whatever it is you told it to be. So here's your equivalent of hello world. If you really want to write hello world, feel free. NS-log hello world. Done. You may actually want to do this because it'll show up in the console. There it is. So let's add some more to this. I called this project light. We've got about 14 minutes to finish up with the class. Let's see how far we can get. What I want to do is just create a simple light switch. We have a light, and we have a switch that allows us to control that light. So let's start with the switch. We can create an object of type UI switch. That's its type. But to make one of these, we need to use a keyword. In Swift, there are two principal ways of creating variables. One uses the var keyword, and one uses the let keyword. In general, you actually want to use let. What let does is defines the name of a variable that you cannot change once it's been assigned. But I need to be very specific about what that means. You can still modify the object that it points to. You just can't have it point to a different object. Once you've created it, you can't reassign it with let. And you should get in the habit of using let. That's the assumption. It's one of those code safety pieces having to do with immutability, in addition to other things. Specifically when you use let with struct types. But use let unless you know that you need something that can change. In which case you use var. So we'll give this a name, light switch. Don't just call it switch because switch is a keyword. We can say UI switch. The only error it's giving me is, hey, you created this thing and then didn't use it. So notice that I don't have the :UI window thing like I do with this declaration up at the top. And that is because Swift uses type inference. Based on what you type on the right-hand side, it tries to guess what the type of this variable is. However, variables can't change type during execution. Swift is very much a strongly typed language. Every variable has a type, but it doesn't require you to type it. So newer versions of C#, for example, you can use the var keyword and don't have to actually say what type the variable is. It's type inference at compile time. I, however, use enough languages that I type everything, even if there is type inference. So you're free to do this. So that is a complete declaration, also giving it an assignment. So that's how you say this is a let whose name is light switch, whose type is UI switch. And if I tried to put in something else in here, it would tell me, hey, that's a problem, because they don't have the same type. So it says, hey, why are you putting a window in there? So teach their own, whatever you'd prefer to do there. We have this light switch. Creating light switch, however, doesn't add it to the user interface. We have to add it to the window. We have to put it into the view hierarchy. That view hierarchy is a window that has a view in it, so we want to add it to the view, not directly to the window. We do that by saying window.root view controller.view add subview. So this will add a subview to my view. So that adds our light switch. And for one reason or another, it didn't put this question mark there. I'll talk more about what all these question marks are for later. But this adds the light switch. So let's see what we get. So we have an app. It has a light switch. It's probably not where you were expecting it to be, but it does work. Just doesn't do anything. So number one, it's sitting underneath like the status area, which is not normal for iOS devices. We also have these black bars, and it's in kind of a weird place. We'll solve each one of these as we go. First, let's move this light switch. So the light switch has a property of where it is in relation to its parent. So we built a hierarchy. Right now, it's more like the linked list. The window has a view which has a switch. But you build out a full hierarchy of views as you build user interfaces. It is a tree that you're building. So this light switch has a position relative to its parent, which is the brown area. And the way that we access that is lightSwitch.frame. The frame property we can assign to. Notice that frame is a CGRect. CGRect is not a class. CGRect is a struct. The difference between class types and struct types in Swift, mostly, is that class types are reference types, whereas struct types are value types. So if I have, so this is just pseudocode, not actually code. If I have some kind of struct type, A, and I set it equal to 5, and I have another struct, type B, and I set it equal to A, and then I say, this is hard, B dot, I don't even know what to say. Here, even better. So that's the main change, sorry. So if I have two of these and I say B equals A, if it's a reference type, A also changes if I change B. If it's a value type, it makes a copy. So this statement has A pointing to B if it's a reference type. It has B as a copy of A if it is a value type. That's the main difference between struct types and class types in Swift. That's something to pay attention to. So it's kind of like primitives in Java. If you have two ints and you have to assign one int to another int, if you make a change to that second int, it doesn't affect the first one, or a struct. So this frame is a struct type. It's called CGRect. We can create one of these like we can with other constructors. Notice that there are several different constructors on CGRect. And the most common one is this. So when you're making a call to a constructor, you have to add labels to each parameter in the constructor, whether it has little names in between or not. So the X component, the Y component, the width, and the height. So let's just put some values in here. Give me some values. Where should this thing go? 50 for X. I'm going to put 0.0 because it's a float. And 50 for Y. Okay. Width. 7,000, negative 100, infinite, nan, 200. Height. 200. Cool. Running. So my switch does appear to have moved. It hasn't changed size though, which is odd. So what did 50 mean? Offset from the left, it would appear. So if I change Y to something like 100, so it's not the same in both. It's taking longer than I expect. Did I not hit it? Go. Deploy. Wow, I actually have not seen anything like that in quite a while. Must have caught it at a really strange spot. Let's build that again. Cool, so it moved down. So 50 from the right, 100 down. Weird. Why did making the Y value go up make it go down?
They want you to work with positive numbers, and since it's starting to relate, maybe go down.
So the origin's at the top left. Okay, that's weird. Any idea why? That seems pretty normal, right? Oh, old monitors. So what did old monitors do? CRTs. They had a scan line that went from the top to the bottom, right? So higher valued lines went that way. This is completely historical. There's no reason why necessarily the top left corner should be the way you do this. And very simple arbitrary change earlier on in the 1970s probably would have resulted in the origin being at the bottom left or the middle. So Y goes down, X goes from the side. But what units is it in? 50. Points. Pixels. So it's actually not in pixels. It is in a coordinate system called points. What are points? Who said points? Yeah.
They just take into account the different screen sizes.
They take into account.
That's not a one-to-one match from pixel to the
Right. So points are not a one-to-one match with pixels. At one point they were though. So when Apple came out with their original phone, the iPhone, it had a screen size of 320 pixels by 480 pixels. And it had a corresponding coordinate system that they still called points at the time because they were looking ahead a little bit and said, hey, we might have other screen sizes, but we don't want software to be strangely busted if we just change the density of the screen. So I have a question for you. Which screen is bigger? iPhone. Wait, huh? Ask that as if you were, let's say I was talking to a kindergartner. Which screen is bigger? Right, the monitor's bigger. But this has more pixels. So it's not that this screen is bigger, this screen has a higher density. And that is actually a very important thing to talk about. Do you need more pixels for something on the screen, or do you actually need it to have a physical size large enough such that the user can work with it with their finger? Are you displaying information, or are you offering a user interface element that needs to be manipulated? On the left-hand side, you care about how big it is in pixels. On the right-hand side, you care about how big it is in physical units, neither of which are captured by points, which is unfortunate. But they roughly correspond to the size of a phone in 2007 on the pixels that it had on its screen. That's what we're working with here. So you can expect screen sizes to be 300 wide-ish and screen tallnesses to be 500-ish. And depending on what other device you're using, that will change. Why did they do this? For completely historical reasons. They had a phone that was 320 by 240. They upped the resolution to be exactly 2x to where it was 640 by whatever 480 times 2 is, 960. And all the existing software just worked because all they did was change the scaling ratio for that and said, hey, a point is 2 pixels wide now instead of being 1 pixel wide. And that was it. And tons of software continued to work. So it was smart of them. But it was also kind of dumb of them because that unit isn't actually physically based. On the Android side, they have the understanding of a pixel for widths of things, and most things are actually represented in widths of pixels, but you also have the capability of expressing something in terms of DP. A DP is a device-independent pixel. They also chose an arbitrary number, said they're 160 DP in an inch, so you can measure things in DP. This desk has a width in DP. It'll be the number of inches wide times 160. So points, unfortunately, doesn't have a physical measure. It does have an approximate physical measure, but not an exact one. On Android, they have an exact physical measure. However, the device manufacturer can mess with that number. So don't go trying to create a ruler application based on DP, because it still might be wrong. Anyway, it is what it is. So I did want to talk about that. Reason why I'm talking about that and why I'm taking so much time to talk about it, it's actually what we're going to be kind of hassling with for the next couple of weeks in class. We're going to be creating our own view types and having those views be interacted with by the user, and you have to lay them out. And that is the topic that we're going to be handling quite a bit, which is layout. Because the main thing that differentiates this from this is how much screen size I have. It also doesn't have a keyboard or a mouse. That's another big change between mobile development and desktop development. But the screen size is the biggest one. There's a lot less physical space, even though there might be more pixels. And properly using that physical space is a lot of what design for mobile does, is effectively use that very scarce resource. So there's a bunch of tools involved with it. And in fact, you almost never will specify things like this. You'll use tools in order to represent a relationship among the user interface elements, rather than just saying this goes here and this goes here and this goes here. Because you want your user interface to scale to different sizes of screens. And that's the concept that you really want to be accomplishing. Anyway, we will finish up with our light next time. I will post this video. Also, on the website, there is a piece of homework that is due January 16th. That is next Monday. There will be a link here to a PDF once I actually put it up there. It's a very simple assignment on the level of this light switch. The intention is to make sure that you have a computer, you have a development environment, you have the ability to use those, and you're able to turn that information into me. Just kind of prime the pump in terms of getting projects out there. So we'll talk more about this on Wednesday. Just wanted to make you aware that you can check this page tonight and it will be available and you can take a look at it. Thanks, guys. We will see you on Wednesday.